So these are the students who completed their summer internship, their SEPnet summer internship from the University of Sussex. First of all, we have Elvira Castello, who completed her placement at NPL.
Hello, so my name is Elvira Castello and my placement was at MPL in the Time and Frequency department. They work in the Typhoon project, which focuses on time and frequency transfer, which is quite vital for optical clocks comparison and application beyond metrology. So my project aimed in delivering a Rio laser system, which can be remotely controlled. So a Rio laser system is formed by a anti-vibration isolation platform, which I developed to the final platform that you can see in my poster, and further optimized for the environment it was placed in. I then focused on the Raspberry Pi connection. So the Raspberry Pi was accessed through an SSH connection, such that we can access it remotely, and it was used to control the current going through the laser through an SPI connection, and then ultimately a temperature controller to set a temperature set point in the laser enclosure. So this system is quite an inexpensive and adaptable solution that can be used in experiments for not only for experiments in time and frequency transfer, but for any experiment that requires a laser with vibration and noise control and a remote access. Thank you.
Thank you, Elvira. Next to complete their presentation is Jordan Ramsey Clements, who completed his placement at Stanbridge.
Hello, my name is Jordan Ramsey Clements. I'm a third-year physics student. Over the summer, I worked at Stanbridge Limited, who manufacture washer disinfectors for hospitals and nursing homes. My role was in research and development, where I was tasked to implement more technology into their existing portfolio of products. This was in the form of a Raspberry Pi, which is a small computing device the size of a matchbox. I programmed the Pi to be the new controller for the machine and developed a touchscreen interface to use the washer. The system now displays notifications, for example, if doors are left open or if this machine needs servicing. Alongside this, fault detection code, which is designed for the servicing engineers. It picks up multiple errors, making diagnosing issues faster, and logs them onto its onboard storage. All these features the old machine never had. I'd like to thank Stanbridge for giving me this opportunity. It's been one that I've thoroughly enjoyed and proud of. Thank you.
Thanks, Jordan. Next to complete their presentation is Henry Thomas, who completed his placement at Rayner. Over to you, Henry.
Hello, my name is Henry Thomas and I'm a third-year mathematics student at the University of Sussex. I completed my summer placement at Rayner. Rayner are the only company in the UK to produce intraocular lenses, commonly called IOLs. These are lenses which are implanted into your eye during cataract surgery to correct your vision after the operation. Currently, surgeons scan your cornea along two perpendicular axes and average out an IOL power to pick the right IOL to be implanted into your eye. However, my project was to take this further and measure not only two axes, but the entire surface of the cornea and come up with a more individualistic approach. I was able to measure over 7,000 points on the eye and come up with some maps which showed the change in power over the eye and making it very much more individualistic and based on the person's eye and not just averages. Hopefully this should lead to, in the future, better vision for people with cataract surgery. Thank you.
Thank you, Henry. Next to speak is Tom Webster. Over to you, Tom.
Hello, so my name's Tom Webster. I'm a final year MPhys student at the University of Sussex. and I completed my SEPnet placement with the UK Atomic Energy Authority. So my placement primarily involved utilising object-oriented programming in Python to develop a simulation for the machine control system of the newly upgraded MAST fusion device. And this fusion device will implement some new research for the Super X diverter and other heat exhaust systems that will be implemented into the new ITER fusion device currently being built in France. And the goal for that device is to have a profitable energy output that will that's currently not achievable with the MAST fusion device or the JET fusion device at the UK Atomic Energy Authority. Thank you.
Thank you, Tom. And last but not least is Callum Yardley, who completed his placement at Photech. Over to you, Callum.
Thank you, Emma. This is Callum Yardley, and I spent my summer working for Photech Limited. They produce and conduct R&D into photon detection products. This includes the multi-channel plate photomultiplier, which they keep aiming to improve as one of their major R&D goals. Essentially, a photon goes in and causes a massive amount of electrons to be picked up by a multi-pixel anode, kind of like a camera image. I was tasked with developing a simulation in Python of such a detector, and I had to try and model each step in the detector's operation realistically enough such that any output data would have characteristic crosstalk. This is image noise as a consequence of one photon being registered by two or more different anode pixels, kind of like a blurred image. Each step in the device's operation was approximated by Monte Carlo simulation, and this involved many complex aspects of the system's operation being simplified to statistical descriptions. To test my simulation, I had to run a laser scan, just like they did in the lab. And you can see on my poster, it's figures 4 and 5. Both graphs have the same characteristic shape, indicative of crosstalk. So it's fair to say that my project has a good degree of success. It is hoped that Photech will use what I've done in future to help develop algorithms to further improve their products in future. Thank you.
Thank you, Callum, and thank you all for completing your presentations. I'm going to pause the recording and then we can catch up afterwards.